Hi, my name is Teresa Scheidt and I will be presenting our paper Time-Dependent Evaluation of Recommender Systems. This paper is the result of a 3-month research internship that I did at the University of Siegen, which was supervised by Jöran Bier. At last year's Rexes, almost 90% of the published papers presented their results in a single number metric, for example NDCG or recall. However, an issue that is barely discussed is presenting results in a single number is sufficient. For example, if we're presented with this result, the only assumption we can take is that all the algorithms performed the same over time, so that the performance doesn't change over time. It could, however, be very different in reality. For example, that one algorithm the performance is steadily decreasing and one is increasing, so that we have a crossing point somewhere where it switches which algorithm performs better. This is especially problematic if this point is in the future. So the algorithm tested now, that we tested now as the best, is not the best in the future anymore. It could also be that the algorithms perform differently over time, so it strongly depends on the time point tested which algorithm is better. For example, here the blue one would be better and here the orange one would be better. To find out how often and to what extent the performance of algorithm changes over time, we tested 4 different datasets in 10 variations and 6 common algorithms. To see how the performance changes over time, we split the datasets based on a timestamp. We split them either on a yearly or monthly basis, and the splitting was done as follows. So the first subset included only the first year, for example, then the second subset included the first 2 years. So we have a growing data set over time, and at the end we test the whole data set. We optimized the algorithms at each time step and then evaluated them with regard to RMSE, NDG, and recall. We found that the performance changes in over 90% of the time. So that we have a changing performance, for example, like here, where the performance decreases in the beginning and then increases again with time. We also found that the ranking of algorithm changed in over 60% of the tested datasets. So, for example, here you can see in the beginning the KNN was the worst, but then it got the best for a few time steps, and then the performance decreased again. So you can see that it depends on the time point which algorithm is the best. Based on these results, we want to initiate a discussion if we should present results more often over time. Thank you for listening, and check out our paper for more details and more results.